So I estimated these values for U and A. You'll come up with your own, and the more you zoom in, the more accurate the value will be. So remember what we're saying about the advantages and disadvantages of these things. It's difficult to know exactly what the exact answer is, but if you only want it to a certain number of significant figures, well then you just zoom in that far. Okay? So I've come up with sort of roughly that 9.81 for the acceleration, U 0.032. This was designed to be 9.81. Anybody recognise that acceleration, 9.81? Right, so this is something that's falling through gravity, okay? And we've basically timed it as it's falling down. So A turns out to be the gravitational acceleration. So now what we're going to do is put those values back into the original formula, which, to remind you again, is S equals ut plus a half at squared. Now we've got our values for U and A. U was 0.032, was it? And A was 9.81. So now we plug them in, and we can write S equals U, which is 0.032, T plus a half times A, which is 9.81, times T squared. So we can put in our values for U and A. Again, we can work out what a half of 9.81 is. So S equals 0.032T plus half of 9.81, 4.9 something, is it? Somebody work it out for me. 4.905 T squared. And now, if you think back to the function we plotted in the first place, we now know our values for U and A. So we had S on the y-axis and T on the x-axis. So what we're going to plot in autograph, y equals 0.032x plus 4.905x squared. So I could literally type that into autograph and I'd have the function plotted. And I could maybe use that to find the displacement at a certain time. Or at any time. How far has this thing travelled? And that's the use of it. It will have gone so far after 1 second, so far after 2. I could just look at it on the graph, zoom in on that particular point and find out what the displacement is. Or I could do it the other way around. How long will it take it to go a displacement of some figure? Okay? So a useful function. To be able to plot this, S equals ut plus a half at squared, I need to know what I've got to plot, what's the dependent and the independent variables, S and T in this case, and given that, I then need values for the constants. And if I've not given them, I need some situation, a situation like this, where we're given the values. I don't know where I put it, it's here I think. Yeah, you're given the values, time and displacement, so you could work out what the constants are. And that's exactly the sort of thing you're going to do in your assignment. Okay, so we've got a few minutes. I'm just going to stop this now.